So thanks everyone. I'm glad to be here. So I know GenAI is the hot topic now, and so what I wanted to do in this talk, I just got 15 minutes. I wanted to talk through a client use case that we, kind of went from nothing to productionized GenAI. We get asked, a lot about where can GenAI impact my company? Where can it drive value? And there are a lot of clients that come to us at different parts of the GenAI journey. Some of them are very new, and they're trying to figure out, which use cases should I target? And some of them are much more advanced. We've dealt with clients that are doing fully weighted GenAI model fine tunes. So it's quite a spectrum that we see. And so with this particular client, large financial organization, but when we started engaging with them, they didn't have any GenAI implemented, right? So the first question that we have to answer is where can this drive real value? And so after you answer that question, then you want to go through building and productionizing the GenAI models. So I'm just going to kind of walk through that journey in some slides here. And I want to leave you with some tips that we've learned after going through many of these GenAI builds. So there, like I said, 3 steps in this situation that we followed. Step 1 is doing a strategic prioritization, right? So which use cases, and one of the talks previously mentioned this a couple times, but I want to find a use case that's high ROI and low risk, right? That's kind of where you want to start, and you just want to get started, right? You want to find some models that you can put into production. People do tend to get hung up on, I'm waiting for the paperwork to clear for an enterprise deal with some company. It's quite easy to productionize some of these LLMs now. And so after you go through this sort of strategic assessment, after we went through the strategic assessment, we're able to identify 3 key use cases that I'll talk through in a little bit more detail here. Upon recommending these identified use cases to the C-suite, we then made the decision, like, these are the ones we want to move forward with. And so then the question becomes, how do we build these use cases, and how do we put them into production in a way that people are going to actually be using them? Like I think someone was saying on the stage earlier, the trick to analytics is getting people to actually use the insights that are being generated. And that's one of the nice things about these GenAI use cases, is that when we deploy them, people understand how to interact with the models because it's a human interaction, right? And so the 3 use cases we identified in this situation were kind of a range, a spectrum. We see several different use cases commonly. A lot of ETL automation is a big one. In this case, the ones we identified were building a RAG architecture, like has been mentioned in some of the previous talks, integrating some of the RAG architecture components with existing enterprise software. So in this case, Salesforce was used. And then additionally, building a GenAI agent that we could embed into the homepage of their main website so that incoming customers can kind of interact, ask questions about the product offerings and that sort of thing. And like was said earlier, it's difficult to build a good RAG solution. We see many people who have attempted or have built RAG solutions, but we see very few people who have built good RAG solutions. And so I'll go through a few kind of tips that we have found in several of these implementations. So I just first, though, wanted to walk through the architecture of the RAG solution. So this was all productionized in Dataiku. It was using some of the newer LLM and GenAI tools that were rolled out in the last few Dataiku versions. But the typical RAG architecture, and in this case what we followed, was kind of step 1, where I have these document icons at the top left of the screen there. And this is a little a little bit of an understatement as to what actually happened. So in this case, we built API connections to different data sources. We set up scrapers to scrape through internal wikis. And we get asked to ingest data from a very wide range of data sources in some of these production RAG solutions. So again, straightforward to do this in Dataiku. So we're able to ingest reams of PDF documents, of PowerPoints, of Words, the common business document suite, and parse through those in an efficient manner. And I'll kind of talk through some practices we've seen in ingesting documents like this, but it is nuanced, right? Like some of these PDF documents can be a couple hundred pages long. At least with where we sit with GenAI currently, we do have limitations around context windows, right? So there is a lot of progress in extending context windows, and a lot of research that's been done on that. But even when you get to the point where you can input a 100,000 character token kind of context window, you're still limited by how much information you can throw, especially when you're dealing with 10, 20, 30, 40,000 documents. So upon document ingestion, we leverage some of the Dataiku tools to build some vector stores. So we tested through several embedding models before deciding on one, and I'll kind of talk through that tuning process in the next couple of slides here. But after creating our vector database, which embedded documents, some nuanced decisions to make there, we productionized a LLM solution, set up some regression testing. So we looked through several LLM models, and then the model was ultimately deployed through the API node in Dataiku. So, what's really cool is we're able to deploy our RAG solution as an endpoint on the Dataiku API node, and it's being called by multiple in sources, right? So in this case, it was being called by the web CMS on the front end. So we had a JavaScript kind of chat application that was making API calls to the API node here. We also leveraged the Salesforce SDK to connect directly from Salesforce to this RAG solution. And lastly, we had kind of an internal app that we used to connect as well. So 3 kind of productionized use cases, all built, using different data sources, but similar kind of concept, right? These were ultimately being used for a variety of purposes to help new employees, to help train new employees, to help access information faster. We had a couple of different personas, customer service representatives and customer representative managers, CSRs and CRMs, that were using this to help close deals with incoming clients, to drive more business coming into their website, make information accessible faster to new potential clients. So going through this process, we see a lot of some of the same kind of pitfalls. So you may have seen an architecture like this before, but there are a lot of nuanced decisions that need to be made when building a solution like this. So I tried to pull out some best practices. Hopefully I can leave you these, and maybe they're helpful to you in your own builds. But the first and most important one is the kind of common ML mantra, right? So anyone who's productionized an AI solution has heard garbage in, garbage out, right? So on more than one occasion in productionized RAG solutions, someone would come to us and say, hey, we asked this question, we got the wrong answer. And upon further digging, oftentimes what is the case is that the data being referenced in the vector database is out of date or incorrect. So it's a process, a regularized process that needs to be put in place to make sure that you're pruning information out of your vector database, keeping it up to date, identifying which documents change. So you might have the same document, revenue, but one document's for 2022 and one's for 2023. So when you run sort of a similarity search through your vector database, it might pull one or the other, and one or the other may be correct, depending on what information you're looking for. And so you have to add, it's helpful to add metadata, and it's helpful to set up those sort of ingestion and automation pipelines to, one, check for changes in information, and two, identify new information that's kind of fallen into your source location. The second little card I have here, this is around the vector database itself. So there are a lot of decisions to be made when standing up a vector database. There are a lot of different options, just in from both open and closed source vector databases, pros and cons to each of them. When ingesting especially large numbers of very long documents, very long PDFs, you have to make decisions around how to split them up, depending on the context size of the model you're using, how to split them up effectively. And then when you're splitting the PDFs, kind of chopping them into pieces so that your embedding model is able to represent them effectively, you have to you have to be mindful about how you allow those split pieces to overlap so that you don't lose kind of continuity going from chunk to chunk. And so oftentimes what we find kind of works best in situations like this is setting up almost like a hyperparameter tuning sweep through your vector database. Here I have a cosine similarity metric, which is a common metric used to identify similar vectors. There are a lot of other metrics as well, right? This, Euclidean distance metrics, non-Euclidean metrics, the cosine similarity here. I've also seen recent examples of people leveraging hierarchical clustering and this sort of thing. So lots of tuning decisions to be made there that need to be made carefully. And I'm running a little low on time here. So card 3 is a formula I put together. Hopefully it's intuitive enough. But effectively, prompt templating was something that was mentioned a couple talks ago, right? So I have a prompt. I have this function T. I'm going to input a prompt P. I'm going to augment it with some additional context with my prompt templating function. And I want to maximize the expectation value of ratings from users given a certain input prompt. And what a trap people fall into many times in these sort of solutions is they'll find a question that didn't give an ideal response, and they'll edit the prompt template, rerun the question, and say, oh, great, now I'm getting a good response in this question. But the problem when you do that is it's myopic, right? So you may be fixing a problem here, but you're creating another problem here. So you need to set up sort of a pipeline that allows you to kind of automate and churn through that in a more programmatic manner. And lastly is a bit further down in the GenAI maturity from what we've seen. Usually you want to, after from a RAG improvement standpoint, the step after improving your vector database, after tuning your prompt, after trying and tuning several off-the-shelf kind of open source models, the next step is going to be fine-tuning. And we have seen people doing fine-tuning first, which is a very valid approach in my opinion. But unstructured fine-tuning through the information in your vector database. So the equation here, we're looking at loss, in many cases cross entropy for LLMs. But we have ground truth values. We have a parameter set theta that's going to kind of control the parameters of our transformer network, depending on the architecture you're working with. And we want to choose the parameters during this fine-tune that are going to maximize the expectation value of our cross-entropy loss during this fine-tune process. So a lot of decisions to be made. I just got a slide here, and again, going kind of quick to stay on time, but I got a slide here, an example of a Q&A kind of process. Someone asking a question, getting returned references, citations. The citations are important to return, really helps reduce hallucination in some of the LLM responses. So let me just jump through here and say thank you, and I'm now -3 seconds past my time, so thanks everyone.